Hello everybody, welcome back to the lecture series of network security. In the last lecture we studied about the OSI network model, and in this lecture we are going to study about the various forms of crypto system. Basically, crypto systems consist of two parts. One is called the classical crypto system and the other one is called the public key crypto system. In classical crypto system, the key that is used to transform the messages to ciphertext are the same for both the source and the destination. And in a public key crypto system, which is also called asymmetric key crypto system, the keys for the source is different from that of the receiving end. That is why the name asymmetric key crypto system. Now let us go over to the classical crypto system. Basically, classical crypto system consists of the encryption and decryption algorithms which are performed by a single secret key, which is called the conventional encryption. Now this encryption algorithm is just the reverse of the decryption algorithm as far as your algorithm is concerned. And types of attack on encryption algorithm are cryptanalysis and brute force. And it basically involves two types of analysis. One is called the substitution technique and the other one is called the transposition technique. This is the block diagram representation of the symmetric cipher model. As before, we have the plain text over here at the extreme left hand corner. The plain text gets transformed to the ciphertext with the help of the secret key K, as well as the encryption algorithm. Various forms of encryption algorithms are possible. Some of them, to name a few, are DES algorithm, AES algorithm, and Playfair cipher algorithm, Caesar algorithm, and so on. Now once the ciphertext is formed, it goes over to the receiving end through the channel, and since you have encrypted it, you have to decrypt again by using the reverse decryption algorithm. And there also you need to have the same secret key K to convert the ciphertext back to the plain text. Now here this key source, you can see, as I said, the key source can be generated by a trusted third party and transmitted to both the source and the destination. Here the key source is there, it is generated by a trusted third party. The key source is called W over here, and it is secretly transmitted to the source as well as to the decryption algorithm to the receiving end. Now there, after the encryption algorithm, you will find the letter Y. Y is actually the conversion of plain text to the ciphertext. There the cryptanalyst or the hacker is sitting to identify the exact replica of S, which is the plain text over there. Now in order to get an exact replica of S, the cryptanalyst should find out the value of W. So that means he is trying to get the replica of W over there, and he is observing the patterns of Y that is going over the communication channel. So this is the conventional crypto system model. Now let us consider a source having plain text S consisting of various numbers, let us say S1, S2 up to SM. That means we are considering 26 letters of English alphabet. Let us say the key W consists of the letters W1, W2 up to WJ, and let us say the letters are only zeros and ones, that is binary letters we are considering. And let us say the ciphertext that is generated is represented by the letter Y, consisting of the letters Y1, Y2 up to YM. So basically the ciphertext that is formed is E of W and S. What is E? E is the encryption algorithm that takes in the key W and operates the key W on the plain text S with an encryption algorithm. That is why we have written Y equal to E of W comma S. Now this is from the source side. What happens to the destination side? At the destination, you want to get back the plain text, that is S. So S should be decryption algorithm of W comma Y. Decryption algorithm is represented by D, and W is the key and Y is the ciphertext that it is getting operated upon. So the opponent actually, he knows the E and the D algorithm, that is encryption and the D algorithm. These algorithms are known to the opponent. From these algorithms, he wants to get an estimate of S, which is S cap, and W, which is W cap. So with an estimate of S and W and operating on the encryption and decryption algorithm, the opponent tries to find out the value of S. Now, as I said, the various techniques of classical crypto systems are substitution technique and transposition technique. Now, what is substitution technique? In substitution techniques, the letters or the bit patterns, if we are using only zeros and ones of the plain text, they are replaced by other letters or numbers or symbols or bit patterns. That means whatever we are transmitting, we are not actually, whatever we are generating, we are not actually transmitting them. With the help of some algorithm and the key, we are converting the letters or the bit patterns to another group of letters and bit patterns and then transmitting them over the communication channel. So that is called substitution, because one letter is replaced by the other letter or one bit is replaced by the other bit. In transposition technique, some sort of permutation is performed on the plain text letters. Here, we are not converting the plain text letters to other letters, rather we are rearranging the plain text letters by some sort of permutation to form the ciphertext. Let's see how we are doing it. Let's go to the first substitution technique, which is called the Caesar cipher. It is perhaps the most easy of all the ciphers that have been devised so far. Here, the encryption algorithm, let's say we are writing it as C, that means ciphertext we are obtaining from the encryption algorithm E is given as 3, P, where P stands for the plain text and 3 stands for the key. Now, here we are using the 26 letters of English alphabet. So, the algorithm is actually P plus 3 modulo 26. That means whatever letter you are transmitting, just let's say we are transmitting letters from A to Z. So, you have to assign numbers to these letters. Let's say A is 1, B is 2, C is 3 till Z is 26. So, you can write it like this, P plus 3, that means the assigned letter, assigned number to the letter, you add it to 3 and whatever the number you get, you do modulo 26. So, this is the encryption algorithm for Caesar cipher that normally we use. But in general case, instead of the letter, instead of 3, you can use any number. Like let's say we can write it as C is equal to E of K comma P. So, we have K is any number, it can be 5, it can be 7, it can be even 2, it can be 10, any number. So, P plus K mod 26, where K becomes 1 to actually 25. So, decryption algorithm can be written as P is equal to D of K comma C. So, K is again, you have used some value for the K. So, what will be the algorithm? You have to subtract the number from the ciphertext. So, C minus K mod of 26. Let's look at it with an example. Let's say we are we want to send the information as P is equal to meet me after lunch. So, MEET MEAFTER LUNCH, and let's say the key is 3. Now, if you apply it on this, that means if you apply the encryption algorithm on this plain text meet me after lunch, you will get the ciphertext C as PHHW PH DIWHU OXQFK. Now, if you are sending it over the communication channel, one who does not know the key or the algorithm will not be able to decipher the message. So, that way we have encrypted the message. Let us go to the substitution technique, which is called monoalphabetic cipher. Here we can use a single cipher element per letter. We can use a single cipher element per letter, and cipher line can be any permutation of 26 alphabets. That is, we can use in factorial 26 number of ways. Actually, cryptanalysts can study the frequency of the data of the original message to break it. They can actually study, like if you look into the English language, the letter E occurs most frequently, and letter Z occurs less frequently. So, by looking at the frequency of this data in an original message, the cryptanalyst can easily break this type of code. The counter measure is to provide multiple substitute, like homophones for a single letter. Like in monoalphabetic cipher, what we are doing, for a single letter we are using a single substitution. But that way the cryptanalyst can break the code by looking into the frequency of occurrence of the English letters. But by using homophones, that means by using multiple substitutions for a single letter, this problem can be removed. Let us look at the frequency of occurrence of English letters. Here we can see the letter E occurs most frequently among all the letters of English alphabet, and you see letter Z, letter X, they occur very less frequently. Letter J also occurs very less frequently. So, based on this frequency of occurrence of English letters, actually the cryptanalyst can use this to break the code.